Hello there. The date today is October 17, 2025, a lovely Friday, and I'm here to introduce a trending article from the archives. Let's see what we've got today. Oh, this name looks fascinating. The title is STEER-MOE Efficient Audio Alignment with a Mixture of Expert Steering Module. The call is Shuts. arXiv v510.13558. Alright, so let's dive into what this is all about. Basically, the big problem in AI right now is how to get two different kinds of AI to talk to each other properly. Like Whisper, which can listen to sounds and speak. And you have another AI that's a genius with language, a large language model, or all like the ones that power chatbots. The goal is to connect them. So you can talk to a super smart AI, and it understands you perfectly. But right, the way people have been doing this is either super expensive and difficult, like rebuilding and training both eyes together from scratch, which takes a ton of computer power and money, or they use simpler methods that, honestly, aren't that great. These simpler methods can lose a lot of the nuance in your voice, or they mess with the language AI's brain, making it a little less smart than it was before. It's a real dilemma, so this paper, STEER-MOE, comes up with a really clever middle path. The core idea is inspired by something called the Platonic Representation Hypothesis. Stay with me. Here, it's not as complicated as it sounds. It basically suggests that there's a universal, underlying idea of things in the world. For example, the concept of any cat. Projections of that same core cat idea. This paper says, maybe we don't need to rebuild everything. Maybe we just need to find a smart way to translate the noun element of an idea into the language version of it. And that's exactly what STEER-MOE does. It takes a pre-trained audio AI and a pre-trained language AI, and it freezes them. It doesn't change them at all. Instead, it inserts a tiny, lightweight AI and steering module inside the audio AI. This module's job is to listen to the audio and gently master the audio data, so that by the time it reaches the language AI, it's in a format that the language AI can perfectly understand. It's like having a master translator who doesn't change the original message, but just presents it in the most elegant way possible. The main part of the name stands for mixture of experts. This is the really cool part. Instead of having one single translator, the steering module has a team of specialists and an audio signal comes in. A router easily picks the right expert, or a combination of experts, for that specific sound. Maybe one expert is good at understanding pitch, another is good at recognizing specific phonetic sounds, and another is good at filtering out background noise. This makes the translation process incredibly dynamic and non-textual, which is way more powerful than a simple static adapter. It's a very efficient approach, training only about 64 million parameters, which is a tiny fraction of the billions of parameters in the big models. Now, how does this compare to other technologies? Well, the first method is anti-infinity. This is the brute force approach. It's like trying to combine a car and a boat by melting them both down. It might work great, but it's incredibly expensive. You might lose the best features of the original car and boat. The second method uses what's called a static adapter. This is like using a simple plug adapter to connect a European appliance to an American outlet. It does the basic job of connecting them, but it's a one-size-fits-all solution. It doesn't have the finesse to handle complex audio, and often a lot of information gets lost in translation. In fact, the paper did an experiment where they replaced their smart module with a simple static adapter, and the error rate for speech recognition jumped from about 2.4% to a whopping 103%. It basically became useless. STEER-MOE result having a smart not only fits perfectly but also intelligently manages the power flow, ensuring both devices work together in perfect harmony. It preserves the power of both the audio AI and the language AI, making them a truly play-to-play system. So where could we see this in our daily lives? Oh, the applications are super exciting. Let's think of 3 examples. Burst in voice technology. think about the next generation of Siri or Alexa. With this tech, the voice assistant wouldn't just understand your words. It could understand the nuance in your voice. It could tell if you're asking a question quickly, if you're feeling frustrated or happy, and it could adjust its response to be more empathetic and helpful. It makes human interaction feel much more natural. Second, let's talk about music. Imagine an AI music composition tool. We could hum a melody into a microphone, and the AI wouldn't just transcribe the notes. The STEER-MOE module would help them understand the feeling of the mood of your hum. It could then generate a fully musical arrangement in that style. Whether it's a sad piano ballad or an upbeat pop track, it connects the raw notion of sound directly to create a generation. And third, for all the gamers out there, this is huge. Imagine talking to characters in a video game. With this technology, LLMs could react not just to what you say, and how you say it. If you shout a command in a panicked voice, your AI needs might react with more urgency. If you whisper a secret to a character, they might lean in and respond conspiratorially. It would make game worlds feel incredibly immersive and alive. Well, and this reminds me of a joke. So why did the mixture of experts cross the road? Because it's read a function computed a non-zero getting score for the other side of the vector. Yeah, nobody gets it. Moving along. What's really impressive is that the paper shows this works. In one test, they gave the model a spoken command in Chinese. Asking, "What's the weather in Shanghai?" The model didn't just transcribe the text. Because the language content and the gentry capabilities were perfectly preserved. It understood the intent and triggered a predefined function call. The function was set up to give a silly answer. And the model correctly replied, "It's raining gold in Shanghai today." This proves that the system isn't just a speech-to-text machine. It's a true audio language agent that can understand the man's spoken commands. So in conclusion, STEER-MOE is a really elegant solution. It's a modular, efficient, and powerful way to bridge the gap between the world of sound and the world of language. It shows that maybe we don't need to build ever larger monolithic eyes. Instead, we can build smarter, more nimble modules that help our existing specialized eyes work together beautifully. It's a big step towards creating more sophisticated and natural AI agents. That's all for today's deep dive into the archives. Super interesting stuff. I'll see you next time. Bye-bye.